In this video, we're going to look at part one for properties of functions, and we're going to determine the intervals in which a function is increasing, decreasing, as well as constant. So a function is increasing in an interval if the y-coordinates increase in value as your x-coordinates also increase in value. So from a visual perspective, your graph is moving upwards from left to right. So as you read the function from left to right, just like you're reading the words on this slide, the graph is going up. From a machine-wise input-output perspective, the outputs, your y values, are going to go up in value as your inputs, your x values, go up in value. Mathematically, if we have two numbers a and b, where a is less than b, function is increasing if f of a is less than f of b. In other words, the value of the function at a might be like right here. The value of the function at b might be up here where the graph went up. So with intervals, we're going to focus on the x-coordinates, and that's going to be a theme for the other two types of intervals in the notes for today's video. Function is decreasing in an interval if the y-coordinates decrease in value as your x-coordinates go up in value. So from a visual perspective, your graph is moving downward. So you might be starting up here, and then you're moving downward as you go from left to right. So from an input-output perspective, your outputs are going down in value as your inputs go up in value. And mathematically, if, again, a is less than b, for decreasing the value at a, which may be up here, your y-coordinate here would be bigger than your y-coordinate down here. So you'd have to go down to get from this starting point to this ending point. So again, focus on the x-coordinates when listing the intervals in which a function is either increasing or decreasing. So keep that in mind. Finally, constant intervals. A function is constant in an interval if the y-coordinates do not change at all in value as the x-coordinates do change in value. So visually, the graph is just a horizontal line or maybe a horizontal line segment. Machine-wise, your outputs don't change as your inputs go up in value. So you keep getting a new value for x, you're just going to keep getting back the same value you have for y. Mathematically, f of a equals f of b for all values of a and b in that interval. So again, just not going to change at all. Going to be a horizontal line or horizontal line segment. Again, focus on the x-coordinates. So let's look at example 1. Determine the intervals for this graph in which the function is increasing, decreasing, and constant. So here we have in blue this crazy looking graph of a function. It is a function, passes the vertical line test. So let's start with the intervals in which it's increasing. So if we start, again, what at the bottom of each slide said focus on the x-coordinates. So focus on the x's. So from -4 to 2, we notice that our graph, our y values are going up in value. So starting at -4, our y value was -3. At -2, it was 4.5. So our y values went up from -3 to 4.5. So we're increasing from -4 to 2. We're also increasing from 3 to 4. And finally, we're increasing yet again from 5 going all the way up to 6. So we are increasing from -4 to -2. That's our first interval. We're also increasing from 3 to 4. That's this interval. And from 5 to 6. That's this interval. Remember, we're focusing on the x-coordinates, not the y-coordinates when listing our intervals. For decreasing, well, we're decreasing from this -2 value here for x all the way till we get to this 3 value here. So our only interval in which we're decreasing is from -2 to 3, this part right here. Finally, for constant, pardon me, we are a flat horizontal segment between x is 4 and x is 5. So our function is constant in the interval between 4 and 5. All right, that about does it for this video. Thank you for watching, and I'll see you next time.